This morning starts the fun of installing all the deck beams, so let's get right into it. We've taken photocopies of all the various pages and stuck them together so we get one continuous line of all the frames as they're installed on the ship. In the book, David developed a number of tools that will help in determining the size of the various beams. And I came up with one of my specials for developing the angles that the beam fits against the frame. You don't have to follow the book exactly, just the principle. I used a solid brass tube, which I made into a square section, and then cut the sliding pieces inside to fit. And it worked pretty good. In any case, by now, if you're this far in the build, you'll be using all sorts of wonderful jigs that allow you to accurately cut and shape the various pieces that fit on the model. And these tools that David came up with are perfect for doing the job. Both Greg and David are suggesting that we put 12 and 11 as the first beams that we install. And so I'm going to take you through that process now. The first thing we do is to set the width gauge, and we do that by adjusting these two pieces through this sleeve. Then we transfer the size onto the beam itself. I like to put a proper square on it. In the case of 1112, the connection is sloped in this direction, but the end of the beam is relatively flat. We've set the angle using the little gauge that we made up, and we can also set the angle that we're going to cut on the side so we get a compound curve. And we've set the table saw with the 1-inch recess. So we simply put it down, and remember this is curved, so you'll have to press it down a little bit. And then we go back and forth, taking off a little bit each time, taking off from both sides to make sure that the beam remains centered. As you get closer to the bow, the curve becomes a real compound curve, and it becomes a little more challenging. Also remember that the recess, the 1-inch recess, also has to be cut at an angle. I have actually chosen to pin them in place because I found that the glue wasn't really holding them, and this just prevents any errors being made. A very useful method to help square against the keelson is to take a piece of wood, any piece of wood, put it square on the keelson, and then use a small square, and that will bring you back to an absolutely square, and we're spot on here. So we got 5 in, the first two, so 12, 11, 10, and then we've got 1 and 2 in, and we'll continue going in this direction and then go to the stern. Even though I had double-checked this, something told me to triple-check it. And I started doing some checks with the caliper, checking long distances from 12 to 9 and so on. And I found a creeping error, which was quite significant. It was the thickness of an entire plank. So I went back onto the book, and I realized that when I made this, two things happened. This drawing got slightly bigger, imperceptibly bigger. And I knew when I was lining it up, the lines didn't line up absolutely correct. And what I found when I did the check is that I was actually 9 inches longer than was reflected in the actual model and on the Mylar plan. So I went back and made up this template, taken off the book, and I used my knife to mark out the points. So now I'm going to have to put all the pieces back in. Fortunately, it does not affect the adjustment at all. And the only thing that was absolutely correct was number 3, because I had done so much checking when I had installed that this one was correct. And again, this will show you that this one is absolutely accurate. Back to that installed centerpiece, that runs absolutely parallel to the keelson below. And then I used a square to make sure that beam number 10 was square to the newly installed guide on the top and to the keelson below. And then I used the caliper, and everything, all the measurements are measured off of 10. The problem with creeping errors is if there was a slight error here, and then you took the measurement from 9 to 8, and then from 8 to 7, and each time you made an error, by the time you reach to 4, you could actually have a 12-inch error going forward. If you center everything back to the center beam, then the error is minimized. And of course, we're using the various locations that have been taken off the book that I'm going to assume that are absolutely accurate. Just to reinforce how we'd use the center as 10 as the center of establishing everything, the first measurement you'd go is from 10 to 11. Then the next one would be 10 to 12, then 10 to 13, 10 to 14, and so on. And that's how you minimize having a compounded error. The one problem that came up was that 17, 18, and 19 at the stern, and at the bow 1, 2, or 3, the caliper was touching the bow or the stern, and so it wouldn't work. So you'd have to use another beam to take the measurements off of. We need to double check any of these long measurements to make sure that it doesn't come back and bite us. The last frame, number 19, is in, and as you can see from the template frame, everything is lined up perfectly. Both the 1 and 2 and 17, 18, 19 were really a struggle to get in. Lots of adjustments, each one probably took half an hour, and a few of them had to be made over completely. Now that the frames are done, we can go back and take them back out and start finishing the internals once more. I have to say it was a lot harder than I thought it would, and I think really what saved me was pinning the frames to the thick stuff on the side. Really allowed me to put a caliper on and make sure that everything lined up perfectly. Certainly I highly recommend putting this strip on the top to make sure you get the spacing right of the various frames. So with that in mind, I'm going to bring this to an end, finishing under 10 minutes for a change, and then we continue the internals.